Greetings. Welcome to our mini project, a biometric system that works purely off generics. I am Hosaya. With me I have Kamogelo, Karabo, and Qiniso.
We are going to dive into automated identity verification via biometrics. Using abstract data structures in Java, the system is built on classification, similarity checking, and pathfinding between targets. It is essentially designed to speed up and optimize biometric identification workflows used within governments using a graph.
They can manage their data from the designed database view to allow them to view and add records. Additionally, they can identify targets such as a face or a fingerprint against their datasets using our identity view, which allows the user to search for targets they upload, knowing to differentiate between a fingerprint and a face. They get the nearest neighbor of the image with a similarity rating and further candidates. So additionally, users can find or can use the Pathfinder to understand exactly how the match they got connects to their search.
Okay, since we can safely assume we have a sufficient dataset of biometrics from the government and we know exactly what we want to do with it, we can focus more on specific types of samples that we can support. What exactly are biometrics? Well, biometrics are measurable physical characteristics that are unique to every person, essentially what makes you you.
We have quite a number of biometric standards, but we will focus only on two of the global standards: facial and fingerprints. Those are the most common used biometrics in today's standard. Used to identify individuals. We can also increase onto the data set through database view, which allows them to either add a new sample or view existing sample with their connections.
Connections, well, our samples are connected to each other and are organized in such a way that each sample's neighbor is their most similar sample connected by their similarity score. And if a single profile has multiple samples, they create a bridge that assumes similarity, essentially allowing us to capture a sample from different angles and allowing us to match them all up to get an anchor of what specific sample is. Our samples are self-sorted through the usage of a heap, which helps us cut down on some computation.
Now that we know what we need, which is the faces and the fingerprints, what can we actually do with those? This means that the detective or the magistrate or the lovely lady at the terminal who checks your passport at the terminal, basically anyone that has legal access to such records, let's say they hypothetically want to identify you from their known, secured, and approved dataset. This, of course, would be visually, and our friendly computers don't really see the world the way or the same way we do.
They actually see in numbers. So the system has to convert your face and finger into a unique sequence of numbers that can be used to identify you. We call this our feature vector, aka the biometric signature, which is a matrix of doubles that denote your biometric sample's structure in a specific picture. We use feature extractors to populate these vectors, specifically HOG for fingerprints to get those curves and ridges, and LBP for faces to avoid vulnerability to lighting.
Again, hypothetically, let's say you are Zinedine Zidane, you forgot to pay for your coffee this morning, and now there is a warrant out for your arrest. The detective has a couple of not so clear-cut pictures of you or your fingerprint from the cut scene provided by the barrister. They want to identify you from their huge cabinet of faces and fingerprints. This now creates another problem. They have to run through every single file individually, practically infeasible. This now also creates another problem, a computational one.
Traditionally, the detective would have had to look through every single individual picture. But then since our system supports that, they can simply switch to the identify view, drag and drop an image, watch the system classify what they uploaded, and click identify. Then they have their target. The rating, however, is very low, which doesn't give the detective the confidence they need.
They perform another search with a different sample, also guaranteed to be new to their dataset. They upload it, but this time before they can click identify, a warning is thrown showing that classification score is pretty low, which is the grayscale problem. They don't know what to do, so they just click identify anyway and automatically match to the same face, Zidane. This time at 54% on the dot, a little lower. They attempt with a third sample that is new to their dataset and match Zidane 3 times straight, and this time with a higher similarity score of just under 64%. The detective is now more confident that the maniac is Zidane.
We achieved this by using those bridges we spoke about earlier to create an anchor feature vector, aka signature, of a single profile samples, which basically boils down to creating an average of the profile. This is how we handle dealing with the unknown, being able to check faces or fingers that are new to our system and at least have a glimmer of hope that a match will be found within our dataset with some accuracy.
We were able to achieve this with Zinedine Zidane and Alejandro Toledo. If we upload a test sample of Toledo we sourced from Wikipedia, the system chokes up a little bit, not being certain if it's a face or a finger, but still having accurate bias and classifying a face regardless of uncertainty, even finding a match and the test being completely new to our dataset. Hooray!
Finally, we can navigate to the pathfinding view where the detective can check on how specific uploaded sample connect with a specific target in the data set. Why? Remember when the detective wasn't confident with why they got Zidane as a match.
So let's say they only had the one sample and needed clarity. They could use the Pathfinder to find exactly how the system concluded that Zidane is the match. We use Dijkstra's for this, strongly relying on our edges, which is similarity rating. Unfortunately for this demo, the dataset was minimized severely, but a quick run through of the system again using the entire Kaggle dataset will play at the end, and we will run the same test for you.